Hey class, how's it going? Here's another podcast here from me. So let's get our notes out. And then I have down here, don't be afraid to ask your sub to pause the video here if you need to take some notes, because there is some notes in here. Also, he should have passed out a worksheet, really not a worksheet, a piece of paper that has the picture of the graphs that we drew yesterday on the board. Make sure that you have one of those in front of you just to kind of follow along as I talk through them. Okay, so let's get going here. This lesson is on absolute value and how to graph it. So the main question here, though, is what is the absolute value of a number? What does that even mean? So when I ask you guys what is the absolute value of -8, you guys know to answer 8, but I kind of wonder why. So you've done absolute value problems before. I just don't think that you have kind of connected it to a concept. So this is what we're going to do. We're going to take look at an important definition of the absolute value to help build a concept of what really the absolute value does. Okay, and then at the end of this unit, we're going to look at some data collection and do a statistical deal to kind of show you absolute value. Okay, so let's define first of all what the absolute value is. So I made a GeoGebra deal here, and this right here says that the absolute value of a number is the distance that a number is from 0. Okay, and distance is always positive, so that's why the absolute value is always going to give us a positive value. Okay, so look what I have here. So as I change some points here, these points, notice there's 2 of them. One's a positive value and one's a negative value. If I stop at 4.4, this point 4.4 here is a distance of 4.4 from 0. So is negative 4.4, right? So as I change this value, you can see the absolute value changing. The absolute value of 4.8 or the absolute value of 8.4. Notice again, we're going to have 2 values here, the negative value of a number, the positive value of a number, but that distance from 0 is going to stay at 8.4. Okay, the distance is always going to be positive. That's one thing that we got to keep in mind when we think concept here. Okay, so that distance, we're just going to represent it with this expression here, the absolute value of b. B just being any number, in this case like 8.4. Okay, so I hope that kind of helps us understand when we think about absolute value. It's the distance that number is from 0, and distance is always positive. So we just want the positive value of that number. That's all that we are concerning ourselves with. And again, I'll show you why we want to do that later, but let's just get practice in doing that. Okay, so that's kind of what we're going to work with here when we think about absolute value. Alright, so let's relate it to the graphs that we were doing yesterday. Okay, so I gave you guys about 13 of these graphs, or these equations, and I asked you to fill out the table. I gave you the input values, okay, all the way down to, or from -5 to 5. Okay, this number 1 here, this is the absolute value of x. Y equals the absolute value of x. We're going to call this a parent function, because as we look at these different equations, like watch, I'm going to flip through here real quick and see if you see some similarities and some differences as I flip through. And look at the dots. I have a purple graph here that's staying constant. That is the parent function, but all the changing graphs are the ones that you guys drew. Okay, so I'm going to come back through here. Do you guys see a lot of similarities? There are differences. Okay, and we're going to talk about what that means. So to do that, though, I'm going to compare it to this parent function here. Okay, this is the absolute value of x if you let x be -5. So we're going to put in this -5 value. We just know that the absolute value of -5 is 5. You put in -4, the absolute value of that is 4. -3, the absolute value of that is 3, and so forth. This is the pattern that we get out. Okay, again, think of this as an x and y pair. So this right here is like my ordered pair here. We'd go over -5, 2, 3, 4, 5, and we go up 5. There's that point right there. If we look at this ordered pair, looks like we'd go over 2, -2, and up 2. There's that point right there. Right? If we go over 3, 3, that means I'm going to put in a 3 on my input bar, and I'm going to get out a 3 on my output axis. Okay, that's key to think about when we look at these graphs here. All this absolute value is going to do is just a number pattern. We're going to put in some number, and we're just going to crunch it through and see what we get out. That's our y value. Okay. So as we look at these different graphs, I'm going to have this purple kind of transparent graph right here. Okay, this thing right here. This is going to be my parent function. It's going to sit right at 0, 0. Okay, that's what we're going to call the vertex too, by the way. So this point of our absolute value graph is called the vertex. So you might want to draw a picture of this in your notes. Okay, this right here is the vertex. It's going to be kind of our key point here. Now, some other features of the absolute value graph here before we start moving it around is notice that both sides are lines, right? And since they're lines, they have a slope to them. If you think, we can go up 1 to the right 1, right? So we have a slope of 1. And then if we look at the left side of the graph, we can go up 1, but to the left 1, which means we have a -1 slope. Okay, so as we transform again, this right side is going to have a slope of 1. This side is going to have a slope of -1. Okay, so keep that in mind too. Alright, let's take a look at another graph here. Oh, one thing I wanted to do here. Some of you guys had questions yesterday when you were plotting these points, whether you should connect the points with a line like this one did, or not, like this graph here, this blue pattern. The reason that we do want to connect the lines is because of this. The table I gave you here just gave you like just some whole numbers here, like -5, -4, -3, -2, 1, and so forth. But understand that in between any two numbers, there's an infinite amount of numbers. So in between 4 and 5 right here, I just pulled out just some random examples of numbers that are lying between -4 and -5. And in between, say, these two numbers, there's an infinite amount of numbers in there. Right? So the way that we represent that is we draw the line to represent every one of those little infinite points. Okay? And because there's infinite points that we can put in any x value, that means that we can get corresponding outputs, right? So that's exactly why we want to draw the line when we draw these absolute value graphs. Okay? Okay, let's take a look at this graph here. Now again, the purple here, this transparent one, that's the parent function. That's just looking at y equals the absolute value of x. Okay, now on number 2, we don't have just y equals the absolute value of x. We have the absolute value of x minus 1. And notice what it did to this number pattern. It looks like, compared to this purple one, the graph shifted over 1 unit to the right. Just like that, right? So I wonder why that is. But if you think about the number pattern, we're putting in a -5. And then we're going to take 1 away from it. So really, we're putting in a -6 into the absolute value, which gives us out a 6. Take -4, subtract 1 from it, gives us -5. The absolute value of -5 is 5. Any number that we put in for x, we're just going to take 1 away from that value and then take the absolute value from it. Since we're taking 1 away from that value, like if we put in -2, we take away 1, the graph is actually going to shift 1 to the right when we do that. To kind of compensate for that subtracting 1, think about the graph as shifting +1 to compensate for that subtracting of 1, right? So inside the absolute value, when we're subtracting 1, notice the graph shifted 1 to the right. Okay, look at this one. Y equals absolute value of x minus 2. Notice this blue graph, this number pattern here with the table. Put in a -5. Now we're taking 2 away. So what that does to the graph is it makes the graph shift 2 to the right. Right? So I'm just moving that parent function to show you the shift, the translation really of the graph. Okay? So that's kind of neat to think about. When we have in the absolute value and we're subtracting a number, it's going to the right, it looks like here. Okay, let's take a look at number 4. We have 2 times the absolute value of x. You put in a -5, we get the absolute value of -5, which is 5, but then we double it and we get out a 10. Say we put in a 3. The absolute value of 3 is 3, double that, and we get out a 6. So that number pattern, okay, is this green pattern here. Notice though, compared to the parent function, it's a lot steeper. Okay, and the parent function, remember, has a slope of 1 and slope of -1. Notice this green pattern. It looks like to go from one point on the green pattern to another point, we have to go up 2 and go over 1. So it looks like we have a slope of 2, which is this number right here, right? This multiplier. Remember, slope is just a multiplier. Okay, so I'm going to move my parent function to have a slope of 2. And see how it makes my line steeper to fit that number pattern? So this 2 out in front looks like it affected the slope of the graph. Okay, y equals absolute value of x minus 4. Again, notice we're subtracting 4. Anything we put in, say -2, we take away 4, we get -6. The absolute value of -6, remember, is 6. Okay, so notice what that did to the graph, this red graph here. Compared to this parent function, the normal absolute value function, the graph shifted 4 units to the right to compensate for that subtracting 4. Okay? So I hope you're kind of picking up some patterns here. Yeah, look at this one. X equals the absolute value of x plus 5. Now we're not subtracting 5, we're actually adding 5 to x. So whatever number we put in for x, say -4, we're just going to add 5 to that value and get 1. And the absolute value of 1 is 1. So if you follow that pattern, notice what that does to, compared to our parent function. It looks like the graph slid over 5 units to the left. So we have a plus 5 here. The graph shifts to the left to compensate, taking away 5, subtracting 5, after we add 5 to x. Okay? Y equals the absolute value of x plus 1. Okay, now notice we have some lines going on in here. These lines that are down here are not going to exist right here, these guys. So I'm going to get rid of them, and the reason is because we are just putting in these x values, -5 to 5, and we can put in anything outside of -5 and outside of 5. I just chose these for the problem. But whatever we put in for x, we're getting these positive outputs out. Okay? So what that means is the graph is always going to be opening up when we have the absolute value of x here, because we're always getting a positive value out, which makes the graph always be positive, like this. Notice we're adding 1, so like we're talking about the number pattern, the graph is shifting over 1 to compensate, subtracting 1 to compensate from that adding 1 here. Because whatever number we put in, we're just adding 1, and then we take the absolute value of that number. Okay? The absolute value of x plus 2, notice outside the absolute value we're adding 2. So whatever we put in for x, say -3, the absolute value of -3, we take the absolute value first. So the absolute value of -3 is 3. And then we just add 2 to that. So every output, if you take the absolute value of, say, 5, you get out 5 and then add 2 to it. Notice we get out 7. So what that does is that doesn't affect what we're taking the absolute value of. It's just adding 2 to every output that we get from the parent function. So what that does, as you notice, shifts the graph up 2 units, right? Every output that we would get from the parent function, we're just going to add 2 to the output, which adds 2 to the y coordinate, which then shifts the graph up. Okay, look at 9. X, the absolute value of x minus 3. So whatever we do, whatever we put in for x, we're just going to get the absolute value of that, which is positive, and then you just subtract 3 from it. So looking at our normal parent function, the normal absolute value of x graph, we're just going to take those outputs and subtract 3 from everyone, which then shifts the graph down 3 units. Okay? 10, we got a half times x. Last time we had a number out in front and it affected the slope, and now look at this one. We have a half here, okay, which means that as we put in any number, like say -1, we take the absolute value of that, which is 1, and then we take half of that number. So as we put in -1, we get out a half. You put in -3, we get out a half, but the positive value of that half of -3, which is 1.5. Okay, so that makes this number pattern look like this. So what it does to our slope here, let me just change this. is it makes it less steep. And if you look at the slope, to go from one point to another point, it looks like we go over 1 and up a half. Or we could think of it as going over 2, up 1, right? Rise over run. Okay? Which is, again, this multiplying number. So that seems to affect our slope of our lines. Okay. On 11, we got y equals the opposite of the absolute value of x. So whatever we put in for x in this equation, we're going to get out this positive value right here, right? The absolute value is always positive, but then we have to multiply that positive with a negative. So that makes that always be a negative output. Does that make sense? So if I put in a negative 5, for example, the absolute value of negative 5 is 5, but then we take the opposite of that and we get out negative 5. Okay, so then what that does is that takes our outputs that are normally positive, like the purple graph shows, but now makes all those positives negative. So then we're just going to take this graph here, and I'm just going to flip it. And this is exactly what we get out, right? This is the number pattern again when we have a negative out in front. It's taking those positive values that we get out from the absolute value, and now it's making them negative numbers. Okay. Alright, y equals the absolute, or negative 4 times the absolute value of x. So, notice again, we're getting positive outputs here from the absolute value. They're always going to get multiplied by this negative 4, which makes the product negative. So we should expect our outputs to be all negative, which they are, and everything that we put into the absolute value, we're going to take times 4. You put in a negative 5, multiply that by 4, and it's negative, gives us negative 20. And what that does is that makes a really steep graph, okay, which then looks like this. So it looks like we have a slope of down 4 to the right 1, so a slope of negative 4 and a slope of 4. Right? Which again is a slope here, that number multiplying our absolute value. Okay, one more. We have negative absolute value of x plus 5. Whoever did this graph probably didn't see the negative sign here, because again, looking at our outputs are all positive, and we know that when we take the absolute value of anything, we get a positive, and then we have to take the opposite. So let's redo this one real quick just to see if we're getting the pattern here. Let's see if we can figure out just from here what the graph's going to look like. So I'm going to get rid of, oops. Well, we'll keep those green points. No, sorry. I'll get the eraser. There we go. All right. Let's see what we can explain what the graph's going to do. This plus 5, as we've seen that in the absolute values, like on number 7, number 6, look at that, absolute value of x plus 5. That shifted this parent function to the left 5. So that's exactly what's going to happen here when we look at this graph. It's going to shift over 5 units to the left. So 2, 3, 4, 5. But that negative, remember, we're going to take all these positive values that we get out of here, right? All the positives from here. And we're going to multiply them by a negative. So what that does is that takes these positive values and now brings them down to the negative. Takes this positive output, brings it down to the negative. See what I mean? So what the graph's going to do, if I were to graph this by hand, if we get out of 0, the opposite of 0 is 0, so the vertex is going to stay right here. But notice all that's going to do is just flip it, and our slope is still 1 and negative 1, right? So this would be our graph here. So if I flip this guy, that is our number pattern, right? The graph of that. Okay, so I'm going to summarize what the number patterns do, or patterns, I'm sorry, I read that wrong. Patterns due to number pattern. Okay, so when we see an absolute value inside, or a number inside the absolute value sign with x, what that's going to do is this number is going to shift our graph horizontally. Okay, so when we have a number inside the absolute value of x, that's really changing what we're taking the absolute value of. So that shifts our graph horizontally. If you have an x minus some number h, it's going to shift that graph h units to the right. So you see a negative, you see a minus, it's going to shift the graph that many units, this h number, whatever it happens to be, units to the right. If you have a plus, it's like subtracting a negative. So when you see a plus here, we're going to actually shift the graph h units to the left. So when you see a plus, the graph shifts to the left. It kind of is backwards of what like I normally think. So I just have to think that when I shift the graph horizontally, when I see a number in the absolute value, it's kind of opposite of what you normally would do. Okay, but if you see a number added outside the absolute value, all that's going to do is take our normal absolute value outputs, and we're just going to add some number to it. So this is going to actually shift the graph vertically k units. Okay, so whatever this k is, the graph's going to shift up or down. If it's a negative number, it's going to shift down that number because we're just subtracting numbers from our output. If it's positive, we shift the graph up. Okay, and again, anytime, make sure that you stop this and write this down here. Okay, you see a number multiplying the absolute value outside. That's going to change our slope. Okay, and the slope's going to be whatever this value is actually. If that number that's multiplying this a value is greater than 0, meaning it's positive, the graph will open up. And if this a multiplier is negative, we're going to take these positive values that we get out, remember, times a negative. So if a is negative, like say it was -2 or -4, negative whatever, the graph will open down. Okay? So make sure you get those notes written down. Those are very important when it comes to graphing. Okay, and we're going to extend that concept when we get into quadratics too. Okay, let's get some practice trying this. So I put the parent function up, and then I have another graph here. This will be our finished graph, this blue one here that I'm going to move. Okay, looking at what we have here, we have the three transformers basically happening here. We have the slope is going to get steeper on our graph because we're going to be doubling every output. We're going to be shifting the graph over 3 units to the right. Remember, we have a minus, so this will graph 3 units to the right. And then the graph will get shifted 5 units down. So we can shift the graph 3 units to the right. That's taking care of the -3. Let's go ahead and shift the graph down 5, 2, 3, 4, 5. And then we just have to flip the graph here so that we have a slope of 2, -2. So we would go down 2 to the right 1, which gives us this slope. And then we have down 2 to the left 1 to give us that slope. So notice now the graph that we would draw, you guys are going to do it by hand so it won't look this cool, but the graph you're going to draw would look just like this, right? Take the parent function and just look at what these numbers do to transform the graph. And it's all about what we put in the number pattern that makes the graph change, right? Whatever we happen to be doing to that input. In this one, we're doing quite a bit. All right. Make sure you write these down. Draw some pictures. Okay, let's look at this one. We've got y equals the opposite of the absolute value of x plus 2 plus 1. So this plus 2 is going to shift the graph 2 units to the left, right? Plus means opposite of what we normally think. I would normally think 2 to the right, but it's not. It's 2 units to the left. And then up 1. Okay, so that takes care of these two numbers that are affecting our number pattern here. And then we have the negative, which is going to take all these positives we would get out and flip them so that they're now opposites. So I'm going to mark the vertex here so I can flip my graph. And then put the vertex back on where it should be. So notice that the vertex, that's going to be our key point that we look at. So that point moved over 2 units to the left and up 1. So did every other point in the graph. And that's why we can take the whole graph and just shift it. So then this blue graph right now is what we would draw as the number pattern, visualization of what this is, the graph of what this equation is telling us to do to some input. Okay, and this is the outputs that we get. Let's try one more. Now whether we have the number -2 out in front or in the back, it doesn't matter. Any number getting added outside the absolute value is going to shift our graph vertically. In this case, oops. In this case, it's going to go down 2 because it's a negative 2. Okay, this negative 1 in here is going to shift the graph 1 unit to the right. So now the graph, every point gets shifted to the right. And then this half is going to make our slope, it's going to affect our slope to be a half and negative half. So that means we would go up 1 over 2, which is this slope here. And then we would go up 1 over 2, which is this slope there. And then that is what, that blue graph is what we would draw. Okay? Alright, so make sure that you got these notes copied down. If you need to, just ask the sub, or go ahead and you can manipulate the video yourself to get the notes. And then make sure that you get the homework done for tomorrow. I will have the answer key for the sub so that he can correct it with you. Okay? So get to work on that, and I hope that this made sense for you.